So children, let's begin with our topic of mass and weight. And now, before I begin with this topic of mass and weight, children, that just few questions for all of you. And the question that can plants grow in space? In space, that the effect of gravity. And can we build and launch rockets from Mars? That the other planet. On Earth, we all experience gravity in the same way. If you work for NASA or any other space agency in India, that is the ISRO, Indian Space Research Organization, you need to have a good understanding of the connection between mass and weight. And you also need to know how both measurements are affected as gravity changes. So these are the few things, children, that mass and weight topic, as you find, this is a very simple topic, and it will take hardly 5 to 10 minutes to understand this topic and to read this topic from your textbook. But the knowledge of this topic, that the application, that the use of this topic is highly used in NASA, in space engineering. So the students who are very interested in space engineering, those students are very interested for the research work, this topic is very important. Otherwise, it's a very simple, it's a one-line topic. What is mass, what is weight, and what is the difference between them? So now we are going to study about the mass and weight. And listen carefully, children. Now here, students, that you have seen in our normal discussions with our friends, with our with our parents, and when we speak with them, means the person who's not aware about the physics, who is not aware about the science, so then they consider that the mass and weight are the same things. We consider in a normal language, we consider that the mass and weight are the same things. But in physics or in science, both terms are different, and there is a huge difference between them. And what are the difference in mass and weight, that we are going to study here. Yeah, Isabel, do you want to say anything? Isabel? No, okay. So here we are going to find out the first, what is mass. And children, now see here this diagram, in this image actually, in this image, that the astronaut Buzz Aldrin standing on the surface of the moon. You can see that the surface of the moon. And why do astronauts on the moon feel lighter? You know that from your previous knowledge, children, that theory of knowledge, TOK. You know that from your previous classes, you have studied from the internet or maybe by watching some news on TV. Why do astronauts on the moon feel lighter? What is the simple answer? Satria. Why do they feel lighter or they feel heavier on the moon?
There's less gravity pulling them down.
Yeah, your answer that we know. Yeah, so you have given the answer. It means you have some background information about the gravity. And so on the surface of the moon, the gravity is different compared with the value of gravity on the surface of Earth. So they have given here, this is because there is less gravity on the moon and therefore a smaller force pulling them downward. And this is the key definition of weight. Okay, they have started the topic from the weight first, not from the mass. Weight. So what is weight actually? If someone asks you that, what is weight? Weight is actually a force of gravity, a pull of gravity on any object. In non-scientific language, people, that I told you, often give their weight in kilograms. But in physics, this is wrong. Weight cannot be in kilogram. Mass is in kilogram. Weight is measured in Newton. Why it is measured in Newton? From the definition, children. And the definition explains us that it is the pull of gravity. It is the force of gravity. It is the force of gravity. And if it is the force of gravity, if it is a force on any object, so then we will consider its unit will be Newton, not in kilogram. So children, my dear student, please remember, mass has a different unit. Mass is measured into kilogram, but weight is a force of gravity. It is a pull of gravity that by which it attracts us, it pulls us toward the center of Earth. and that is measured in Newton. So I will show you a mathematical equation of weight also, but before that, let's discuss some more here. When astronauts return on Earth, they will go back to experience the same amount of gravity as before when they leave the planet, and nothing about the astronaut has changed, only the force acting on them, that is their weight. So when the one astronaut is on the surface of Moon, and when the same astronaut is on the surface of Earth, they will experience the different kind of force. Why they will feel a different kind of heaviness or lightness? This is due to
Sir,
the effect of gravity. Yes, Vansh.
so weight is the gravitational effect on an object, right?
Yeah, that in terms of gravity, we will. Yeah, I will give you a mathematical equation, then you will find out that how this gravity is making it a very important factor compared with the mass. So now here, children, here in this image, in this picture, you see the different kind of objects. A different kind of object means that the different shape of objects, different size of objects. Everyone are stone, they are the piece of rock. And if they have different, from this diagram, some are of small size, some are of large size. In terms of mass, means some objects are heavy and some are lighter. Light in their mass is less, or maybe their weight is less. So the quantity of matter in an object is that mean by the mass. If someone asks you, children, that what do you mean by mass? So mass is what? Mass is the quantity of matter, children, that you need to remember. These three words are very important. Quantity of matter. Quantity of matter, that is mass. That is mass, children. Quantity of matter. And if it is related to the matter, if it is related to the matter, children, so whatever the small to smallest matter, even we consider the atom, the lightest particle, the smallest particle. So these smallest particle, atoms, they still have some mass. Why? Because what is the definition of mass? It's a quantity. It's a quantity of matter. So from this discussion, children, we can conclude, I think, that mass can never be zero if we have an object. Mass can never be zero, but weight of any object, means your weight, children, your weight, my weight, it can be zero, depending upon the one factor that is called the gravity, force of gravity. And we know that this value of gravity is different on the different planets. Now, I think I need to go to the mathematical equation of weight. Let me find out where it is written. Measuring weight. Yeah, we have this equation, children. I want to come to this topic here. Weight is given by this very famous equation, which is mass multiplied by gravitational field strength, whose unit is Newton per kilogram. And what is this? You can read here. Every object on the earth is pulled towards the earth's core due to the strength of gravity. And this is called the gravitational field strength, which is represented by the letter small g. Small g. Every matter, every material, every object is pulled towards the earth. Let me show one diagram, children. You see this picture here, children. Here on this diagram, you can find we have the two different mass object, 1 kilogram, 2 kilogram, and they are pulled by the force of gravity. And then you can see that the weight, in terms of weight, first object has weight 10 Newton, second object has weight 20 Newton. Why there is difference? Why there is a difference? Because here now we have a mathematical equation, and that equation is, which is given by weight is mass multiplied by g. On the surface of Earth, we consider that the value of this gravity is G is 10. So the mass, so weight is depending upon, mass is mass, but the value of G, if I put the value of G 0, so the weight of the object can be 0. But even though that if I'm taking a matter, a small particle, maybe atom, still it has some mass. So students, please remember, mass can never be equal to 0 if we have certain material. Weight, W, it can be 0. It can be 0 depending upon this factor, gravitational field strength. Now let me show some value of this gravitational field strength from, there is a table and you can find this value. On the surface of our children, please remember, the value of this gravitational field strength is 10. On moon, almost this is 1.6. Jupiter, 23. And we have seen that how this gravity also affects, that the time period we have seen in the pendulum demonstration. Saturn and the density on the surface of Earth, sorry, not the density, gravity. It is also 10. Both have the same value. You can also cross-check whether these are the same value written on the internet. Okay, and on the Mercury, it is 3.7. Mars, it's also 3.7. Sun has the highest value, 270.0, or maybe that the black hole has a different kind of gravity. So these are the value, children, and I will suggest you no need to memorize all these things, but just remember that the Sun has the highest, Mars has that 3.7, and Moon and Earth. Just remember in that way. You don't need to memorize. If there is certain question, you will find their numerical value in your question paper. Now let's do some question, children, that we have discussed here, the point, mass and weight. That mass can never be 0 because it is a quantity of matter. Weight can be 0 because it is completely depending upon the value of gravity. Now one question, children. When Neil Armstrong wore his spacesuit, his mass was 160 kilogram, 160. And now the question is, you need to find out what his weight on the surface of Earth and on the surface of the moon. Children, please do this calculation. Weight, you need to calculate. Whenever you have find such type of questions, first write down the equation, mass times gravitational field strength, G. Now here mass is given 160 multiplied by the gravitational field strength. What is the gravitational field strength on the surface of Earth? I'm on the surface of Earth. I'm doing this part here. Let me write here on Earth. So this will be 10 here. Then the weight now 1600 Newton, children. This will be Newton. If you write here kilogram, gram, your answer will be considered wrong. I want to calculate his weight on the surface of moon also. Weight on the surface of moon. Again, the same equation, mass is same. You know that the mass is same, children. It means, we can also conclude from this, whether you are on the surface of moon, whether you are anywhere in the space, that mass, whatever your mass is on the surface of Earth, it is going to be the same on any other planet. Mass is not going to change, children, but weight change because G change. What is the value of G on the moon?
1.6.
1.6.
Okay, students, even if you can remember, 1.6. So if I remove this decimal, then 10 I need to put here. This will be cancelled out. 16 multiplied by 16. May I know how much is this? 16 multiplied by 16.
256 newtons.
Let me do this in my mobile phone also.
Sir, it's 256.
256. And unit is also important. Unit, if you don't put the unit, then there is a penalty of 1 mark in exam. Let me check here that what they have done here in the solution here.
Sir,
Weight is
can you
mg. Yeah, that we, yeah, 6160256 Newton is the answer. Yes, please.
sir, can you scroll up? I need to
Okay.
see gravitational force of different planets.
This one?
Yes, sir.
Okay. Yeah, you will find the same table in your textbook also.